This is homework 5, question 1. From the question, we can see that x and y are independent with fx of x is equal to u of x minus 1 minus u of x minus 2. And fy of y is equal to u of y minus u of y minus 1. And z is equal to x plus y. And ask find f of z of z by the first subproblem convolution method. So the convolution method fz of z is equal to fx of z convolution with fy of z. So it is like integral of minus infinity to infinity fx of alpha times fy of z minus alpha and d alpha. So based on the fx of x is equal to u of x minus 1 minus u of x minus 2, we can draw this diagram. So u of minus 1 is start from 1 and the magnitude is 1. u x minus 2 is start from 2, magnitude is same as 1. So ux1 minus ux2, it turns out to be this region has magnitude 1. And same for fy of y. So it is u of y minus u of y minus 1. So it turns out to be this one. So in the region of 0 to 1 with magnitude 1. So these two convolution fx of x convoluted with fy of y. So based on experience, this one gonna flip to the other side. So it's in the region of minus 1 to 0, and the magnitude is 1, and it starts to shift from in the region minus 1 to 0, start shift to the right, and see where is the common area between these two. And we can draw like when it reaches 1, it starts to have common area. So it is here like, and move forward, the common area gonna increase linearly. And when you reach 2, these two blocks are totally the same. So it's gonna reach 1, and after that the common area gonna decrease linearly. So when it reaches 3, there's no common area. So it's like this triangle diagram. So based on this diagram, we can write like fz of z is equal to z minus 1 u z minus 1 minus 2 z minus 2 u z minus 2 plus z minus 3 times u z plus 3. So this is the first subproblem using convolution methods, and the second one using the geometric methods. So this one we're gonna think about like when fx of x is equal to ux minus ux minus 1, and fy of y is equal to uy minus uy minus 1, and the big PDF z of z is equal to the probability of z less or equal to z. So it is the probability of x plus y less and equal to z. So actually there are 3 situations. So the first situation, z is less and equal to 1. So we can draw this diagram. So x-axis, y-axis, and this is 1. So when x is less than equal to 1, it is in this region. So the shaded area is the common area, so it's a convolution area. So the big PDF of z is equal to probability of z less and equal to z, which is equal to, so this is c and this is c. So just using the triangle area, so z squared divided by 2, and we can get the small PDF by differentiate it, so we can get z. And another situation is when z is equal larger than 1, less than equal to 2. So same process, and we can draw the diagram like x, y, and when it is larger than this, we need to find this. So this is the common area, and this one is z, so this square is z squared divided by 2, and we need to minus these two small triangle. These two small triangle is z minus 1, this line and this line is the same. So z minus 1 squared divided by 2, and we have 2 times 2, so it is equal to z squared divided by 2 minus z squared minus 2z plus 1. So finally you got minus z squared divided by 2 plus 2z minus 1. So when differentiate, you got minus z plus 2. And for the third situation, when z is larger than 2, we can see that when z is larger than 2, so this is y, this is x, there's no common area between the there is the common area is the whole block, so it's gonna be 1. And if you differentiate, it's just going to be 0. So we can write, we can draw the diagram of small PDF of z. It is same like this, and because we set fx of x is equal to u of x minus ux minus 1, so the original one is ux minus 1 minus ux minus 2. So we're gonna think like we shift this one to the right 1 step, so also the convolution gonna be shift to the right 1 step. So this one gonna change to this one, so it's same as the convolution methods, the diagram of convolution methods. So the formula is the same. So this is question 1.